Hi, my name is Colin Davidson. I'm bringing you our regular show, Unwind, today with special guest Alex, one of our longtime contributors to the handmade community, and co-host today, Ben Business.
Hello.
So today we've got a bunch of cool projects done by Alex. We've got a drawing tool, we've got a CPU pipeline graphing tool, and a chat application as well. So I'm excited to kind of dig into them. Let's start with the drawing tool. So what was your inspiration for this drawing tool, Alex?
Well, there was, first of all, hello. Nice to see you. And it was not so much an inspiration, but as it usually goes, it was an awful product that kind of, let's say, kicked off the development. Unlike many of my other projects, this one has an actual user and a use case.
Okay.
The user is my wife, who used to teach kids math. And obviously, after 2020, you do that remotely using some kind of a whiteboard multiplayer thing. At the time when she was doing it, it turned out that, well, let's say all of them either suck or are paid. And my words to her at the time were literally, I think I can make that in like 2 weeks. And here we are, I guess 3 or 4 years later. It's still not finished. But as far as inspiration, that's about how it goes.
That makes a lot of sense. It's a common one. You run into something that you're just like banging your head against the wall on and like, well, okay, I should replace this. And there's always some of that you can't take that long to replace this, right? A couple of weeks and I'll have something awesome. Well, sometimes it does take a little while.
Yeah. I got to say, though, the version that you came up with is far more than just the kind of MVP whiteboard app. It is actually a really technically impressive project that has been really fun to see the progress of over the past couple of years.
I did, of course, fall into a few rabbit holes and optimizing stuff that probably it's not that important for the product. But thankfully, I'm not working on a product. I'm working. Well, I took so long that my wife stopped teaching kids, so the deadline is no longer there. It's just the project where let's say, if I'm in a mood to program, that's what I jump to. There have been a few fun technical challenges that I'm not aware of any other similar whiteboard project that solved them in a similar way to a similar scale. But about the polish. So I drew all the icons myself in Inkscape. I made all the like styling for all the elements, and it just sometimes fun to switch between like hardcore WebAssembly, SIMD, multi-threaded, whatever level of detail engine, and sometimes I just want to draw a pipette or whatever.
Would you be able to demo it here?
Yeah, no problem. You can draw lines, whatever. You can zoom in and out to about as far as floats would allow you. Right now we are at 1,600 or whatever. We can go to like about 10K before it breaks. And the same for the zoom out. It's almost unlimited. I also made it such that there is unlimited undo. The history doesn't get lost when you reload. Yeah, you can just hop in and undo everything you've ever did.
And does that work with multiple people? Do they each just undo their own
strokes? Right. It's multiplayer. So you should be able to see the other users on the canvas. And if I go here, you can see this one there. You can do the thing where you are like following the other user. So you can press this and you will see what he's seeing, which is actually surprisingly useful for the lessons, because a common problem is, I heard this phrase maybe like a dozen times, when the teacher is drawing and the student has no idea where the teacher is drawing. So they like clumsily communicate to like, can you please zoom out? Okay, go a little down, now to the left. Okay, you missed it, go to the right. So the idea was that the teacher would like log the user to their screen and they will just see everything. Yeah, and so, okay, you asked about different users. Let's denote the left one in violet and let's say the right one in black. And of course, this one undoes his, and this one undoes that. It all works fine. And another nice thing is that it actually supports mobile, because many kids apparently don't have any form of a PC or laptop. Yeah, that's from mobile.
Nice.
You can, yeah. So many teachers joined from a tablet or even a phone, which turned out to actually be a really peculiar optimization case. We will, I guess, talk about it a bit later. Yeah, and as you can see,
I remember you posting a lot about the challenges of getting the performance where you needed it to be on mobile, and seeing some of the test boards that you've shared. I think I understand a little bit of why.
Yeah, this one is like the one I jumped to. It's like it's the board number 1. I just draw on it whenever I want to test something, and actually I even use it for real sometimes. You can, I think, here to the top right is where I figured out the circle subdivision thing, which turned out to be a single, very simple formula, but I, of course, overcomplicated it. So I actually do use the whiteboard, mostly for work, and I obviously can show that. Yeah, and the scale, well, at this point, let's see, a little bit below 5,000 strokes. Each stroke can have hundreds of points, or some have thousands, like longer ones. Yeah, so the scale is there. And of course, the big boy, the father of all whiteboards, is this one, which is not empty, as it might seem from the first look. But I actually contacted Casey of Handmade Hero fame, if he could maybe give me his Milton save file from the Handmade Hero whiteboard, and he very graciously provided it. And if we zoom out, I did import it into my thing, and it's all here. It's not very easy to see when you zoom out.
That's incredible.
But all like 200 plus days are all here, and it's working fine. Yeah. And a fun fact I was sharing with Ben before is Handmade Hero whiteboard is actually drawn at an incredibly high scale. So if we assume one unit is 1 pixel, right now we are zoomed out by 30 times, right? So if we zoom in to the default zoom is this one. So this is the top of the letter T, and this is like the joint. And we go down, down, down. Let's zoom out a bit. Down, down, down. Zoom out more. Okay, we're almost there. Okay, so this is the bottom of the letter T.
Beautiful.
Yeah, so the whole whiteboard is incredibly huge. And because of that, when you go to the end, it actually only looks fine at this scale. But when you zoom in, you will see that my floats are not quite holding up. Also, you can see, maybe you can see in the video the background pattern. It gets all stretched out. And if I, God save me, try to draw, it will, yeah.
Oh, wow.
I guess that's, yeah. So the case is whiteboard is, as I said, exported from Milton, and Milton uses not floats, not doubles for the point coordinates, but 64-bit integers. So it measures in points at the most zoomed in scale, which is why it's also huge, because no one draws basically at the most zoomed in. They like draw at some middle ground. But Casey has been like his whiteboard example has been extremely not careful, but helpful. Because before I imported it, I assumed the performance was fine.
Yep.
Yeah, but then like there is what is it, 78,000 strokes over the course of, was it 5 years or 4 years? Yeah, and this is when I realized that I have to like implement a level of detail scheme and all that, which was
so what
fun.
was the performance like when you first imported it into the system?
Right, I have a video of that somewhere. I think it's 8 million points on the whiteboard, and at that time, each point was drawn as a separate, I think, a few quads. So it was like 10 or 15 million quads, and even though they covered 1% of the screen at full zoom out. It was not good on the GPU. Just all the vertex processing, etc. I think the frame time was around maybe a second.
Okay. Yep.
Yeah, when drawing everything, which is not ideal, I guess.
It's still actually a little better than I might expect, but yeah, not ideal.
Seconds per frame is still within ballpark, right?
Well, let's put it this way.
Single-digit seconds per frame.
Right. If you import into one of the popular whiteboard projects, maybe TL Draw or Xcalibur Draw, well, TL Draw would, how we will put it gently, need a fresh pair of pens, I guess, because they draw using SVG, if I recall correctly.
Oh my, okay.
Yeah, so you can imagine what will happen if you like do 10 million SVG curves, or I guess not even 10 million, but 80,000 SVG curves. And Xcalibur Draw, I believe, is either WebGL or Canvas, but its performance is not ideal. I think they are doing a draw called per stroke, which is not something you should do. Yeah, but that's what most of those packages are doing. They're either using SVG, which gives you like amazing quality, and you can like transform and warp all your strokes and all that. But it doesn't scale beyond just about 100 maybe strokes on screen at the same time.
Okay, yeah.
And you have to do the usual web, like let's remove the DOM elements that are outside of the viewport, and please don't zoom out. Those that are not using SVG are very few and far in between, and they are doing some very weird, when you zoom in, I'm not even sure how it works, but it like jumps to a rasterized low quality version, which becomes crisp when you move. I'm not even sure how they're doing it. I tested, believe me, quite a few whiteboard packages, and basically only Milton, which is a native application, handles things to the similar scale.
Using a 64-bit makes a lot of sense to me.
Yeah, it does. It does. I should have done that.
Well, JavaScript. Is this entirely JavaScript?
Well, it's entirely running in the browser,
Okay.
but it's not entirely JavaScript, right?
Are you doing
so-
some Wiseman?
Yeah. So everything is in JavaScript besides the level of detail code,
Okay.
which is the thing that runs per frame and simplifies the curves. For example, right now, we are basically seeing all the strokes and about 35,000 segments. But when I zoom out, the curve number stays the same, but the segments one drops. It is like discarding points from the curves, so that the difference is barely noticeable.
Right. You like discarding when you get to a pixel or two?
Yeah, basically. Yeah. I'm using a curve simplification algorithm. And because of the implementation of the engine and how it works, it was basically the best way to do it was for me to run the level of detail code per frame. So it's running every frame, which, you can imagine is quite intense on the CPU. You are ingesting to the order on this whiteboard to the order of like 1 million points, and you output whatever 50,000, but you need to do that in a few milliseconds. So it's all the way. It's multi-threaded WebAssembly with SIMD.
Oh, you're going to
code
fancy
math.
stuff.
Well, the SIMD wins are quite marginal, maybe like 20%, not 4x, like you would hope. The biggest jump of in quality from going to WebAssembly was actually getting rid of the garbage collection poses, which is why I originally did that. I tried to first optimize the JavaScript code, as I guess you should probably before jumping to C. And it was close, but it gave the annoying poses. Because all the intermediate values of the computations are allocated on heap, as I learned from our friend Martins on the Discord. And you just don't do intense mathematics in JavaScript, I guess, without getting the poses. So that was the biggest win. And then, of course, you get the SIMD, and then you put the WebAssembly one thing in the web worker, and you launch 16 of them or whatever. And from that point onwards, it was fine.
Okay.
Nice.
So what did you run into when you started moving to mobile support? I'm sure that's interesting.
Actually, surprisingly few problems.
Okay.
Most of them, or I guess, like all of them, were problems with basically UX and interactions, not compatibility. Because I'm using quite basic stuff, WebAssembly, WebGL2. It's all supported in like the browser I have, I guess, except Safari, if it's not the newest version. But the compatibility issues were very minimal. Maybe I used some fancy JavaScript thing somewhere and I just replaced it with the old one. All the complexity came from the fact that the gestures you would expect to work on the phone, like, for example, pinch zoom in, is not actually a thing built into the browser in any significant way. So you have to re-implement the UX of the, for example, pinch zoom in yourself, which is not so hard to do. But when you take into account that you also want to draw with one finger, and there are all those fancy edge cases where you don't want to force the user to touch with two fingers at the same frame. You want to give him some leeway. Yep. So he starts drawing, and maybe for 100 milliseconds, he can touch down the second finger, and so he will start dragging. So you have to send a cancel message to all the other clients so that they erase the half-drawn stroke. It's been surprisingly fine, actually. The renderer worked as is, I think, which was really surprising. And not surprising, but it was pleasant, because that's the point of using the web stack, right? It's supposed to be compatible with everything. And in my experience, it's compatible with, let's say, not counting mobile Safari. The experience been basically it works as is.
Yeah, the issue I ran into when I did mobile WASM stuff was definitely that for a while, and it's gotten better, but mobile WASM performance on Safari especially was garbage. How did your memory footprint kind of land? Where are you at?
Well, I converged to a very minimalistic representation of the data. For example, the strokes, even the GPU buffers, which are supposed to be the explicit things that repeats everything, they're pretty minimal. I'm doing instance rendering for everything. So every segment, not as a stroke, but every segment is an instance.
Yep.
And actually, in fact, I don't even make a difference between a real segment and a phantom segment connecting two consecutive strokes. It is just not drawn because a flag is passed, but the data is all there.
Okay.
So what I do is I have a huge array of points with vertex attributes set up such that the points get reused, so that each instance gets 2 points. Okay. So I don't have to repeat the shared point for the next instance. So the footprint is about how you would expect. So if it's whatever 1 million points, multiply that by 2 floats for X and Y, and that's a footprint, basically.
That's really not too bad.
Yeah, not counting the textures. They live in GPU memory anyways.
Very cool.
I do find it somewhat remarkable that you could port it to mobile and have it mostly work. I guess I would have expected the graphics situation on mobile to have more restrictions or something, but ultimately, is this just not actually that much GPU work at the end of the day?
Yeah, exactly. So, well, I guess maybe the GPU does a lot of work, but it doesn't use any fancy features. So the fanciest GPU feature I use is maybe instance rendering, but that's not something you would consider optional, I guess, to implement. It's all very basic stuff, basically just vertex buffers, instance rendering, and a few textures that I use to look up per stroke data, for example, like color. Yeah, so nothing fancy, which is, I guess, how you should do things if you want them to be compatible.
Very cool.
I want to talk about the chat thing in particular, because one of the things that I've appreciated about Alex's projects is that he jumps in to these web projects and immediately does them better than any other project on the internet.
Immediately is a bit of
instantly, day one, you're like, here's the better thing, now.
Well, but the first thing that you put out just kind of doesn't have the problems that the main players in the space would have. And I think that's very true of the chat app.
So I was quite lucky at my last job. My then boss allowed me to spend some of my time making a chat replacement. Let's say went with his larger concept quite well. Yeah, basically I went all in and made a full-blown, let's not say Discord replacement because there are no calls, but something like an internal corporate chat thing you would use, like Mattermost or Rocket Chat.
Yep.
Which this was a direct replacement, and the title is a reference to. It's a thing that is designed to host like hundreds to maybe up to about 1,000 people, which is a significant actually design consideration. Because, for example, what I did was on login, you download all the messages to your client.
Okay.
They all get cached, I guess, and also expanded in memory, which is not a bad idea if you think about it. Because what's the size of a message, right? It's like 100 bytes. With all the metadata, yeah. So, yeah, a megabyte is like 10,000 messages. A million messages would be 100 megabytes, which is quite reasonable to fit in memory nowadays and not think about it. And a million messages is not a thing you often see in a corporate chat.
Right.
People don't tend to spam like they do on Discord or whatever. So that was one thing that allowed most of the improvements, because I don't have to stop the scrolling to load more messages when you scroll up. Okay, so I opened like an actual work chat history. You can see the scroll bar to the right. What I used as my benchmark when I was doing these things is this very fun thing where you just hold page up. Everyone who has a chat available to them, try doing that. And basically just scrolls, right?
It's so beautiful.
When you think about the amount of data you're pushing around right here, that should not be surprising.
Exactly. The thing that surprised me, actually, you might have noticed that when I scrolled in the blur chat, the scroll handle was only getting smaller. So I was not removing any elements getting off screen. I was only adding elements on top, which is, I guess, not what people usually do. You can just have like 10,000 message elements and it will work fine, absolutely. The rule of thumb is that 10K is fine, 100K is pushing it. So 100K might lag. The thing that actually surprised me, constructing the elements is damn slow, and adding it to the DOM, it can take like up to a millisecond.
Wow.
So you have to be very careful to not introduce lag spikes. What I did was like find out empirically a number of elements that you can safely add during one frame. And I think it's 10 right now.
That's so sad.
Yeah, so when you like load a new chunk of messages, I like prepend the actual elements, 10 messages a frame over a span of several frames. I guess TAA memes, basically.
Okay, that is really sad though. That's
unfortunate.
That it would be that fast to render all of those elements, to do the layout, to do the text rendering and all that, but that the bottleneck would be on just allocating the nodes. And
not allocating the nodes. Adding the nodes. The layout is the part that's slow, because you add elements to the beginning, and browser can't, for the life of it, believe you that the elements below it are not affected. So it likes relay out this whole thing of 10K elements below it. But you should talk with a browser engineer to be sure I'm not like 100% of it.
Oh, I didn't introduce myself at the beginning of this show, did I? Whenever you do this in Discord or Matrix or any other chat service I've ever used, not only is it super slow and painful as it loads chunk after chunk of messages, each of which is like this pathetic little chunk.
Yeah, 25 messages.
Yeah, right. Which is
on Discord.
Why would you ever want any more than that? Can you provide any insight into why they are losing your place all the time?
So I, of course, have the jumps, right? You can attach files. Let's click the message. Let's see what happens. It jumped to the top, right? To the top of the. It did not load all the messages. It actually jumped and rendered the surroundings.
Well, and importantly, it jumped to the message you actually clicked on, which is another thing that Discord can't do.
Yes, exactly. I did have quite a few problems with implementing it. Even now, you can find cases where, like on F5, it will scroll a little bit up, which I guess just goes to show how insane the ecosystem is. But basically, yeah, it is quite tricky. And the more you fuss with virtual elements appearing and disappearing, the worse it becomes. So I'm not too surprised that jumps all around on Discord. If you don't save the image size independent of the image itself, it will jump around when images load, which is also not good. Everyone who is actually unfortunate enough to be implementing it for some reason, I encourage you to Google what scroll anchoring is. Of course, it's not available in Safari, but other than that, it's basically the thing that makes it work. And nowadays, it's enabled by default. So for example, if an image loads off screen in a scrollable buffer, if it loads below the viewport, it won't affect your scroll. But if it loads above, it will scroll to the same amount up automatically. So you don't have to do most of the things you would assume you have to do. What you have to do to like have precise jumps and no weird jumping back and forth is not break scroll anchoring and implement it manually on Safari, which is not ideal.
Sad.
So the chat, right? Almost a feature complete thing. There are DMs, like here are my DMs with Ben. You can try typing in something if you want. But like, yeah, you can see he just read the message. Yeah, right. Oh, there are even notifications. There
I just got the notification too. So
right.
It went away.
So there are markers for when the message is read. There are all the things you would expect. Please don't click thread. But other than that, you can reply. There are like date indicators. You can attach files. Yeah, right.
I'm curious, like what this looks like under the hood. So we've got, is this like WebRTC doing your?
It's a binary protocol over WebSockets, which is, by the way, also the things that I use for the whiteboard. So I don't do the JSON thing because I don't see a reason for it.
Sure. Yeah.
Yeah. All the backend is written in C. I actually even did the roll your own database meme, which was maybe not the wisest of ideas.
It was pretty amazing to see when you did your presentation to the network, though, in the Discord.
Well, this is probably one of the simplest examples of a database. So you're probably in like almost okay territory, right?
I made some choices to make it simpler. Okay. But I still don't recommend rolling your own database because just the disk persistence thing is hard to get right. Yeah.
What are you actually storing per message? Is it like the message data plus a timestamp plus who sent it?
What the server and the client are doing are basically synchronizing event lists between each other. Each channel has a list of events. The events are messages, but also all the other like message deletions, message edits, replies, reactions, users joining and leaving. Basically all the things that you want to save. Yep. The job of the client is to push the event to the server reliably, which is why I have the whole TCP-like syn plus ec mechanism, where you keep a local queue of events on the client, and you send that with a sequence number to the server. You only stop retrying and delete it from local storage after a server has acknowledged the messages. In conditions of bad internet, where you are typing messages while the other older messages are getting sent, there can be several, say, packages that are getting sent at the same time. Right. And the sequence number takes care of that. It helps you deduplicate. It helps you prevent double sends, which is not a thing that happens in this chat, because each message is marked with a sequence number. And the server is doing basically the same thing. There are two sequence numbers in both directions, right? So the server is doing basically the same thing. It has a global event list per channel, which is a collection of all events from all clients sent messages to the channel. And it synchronizes, pushes the data to all clients who have not reported receiving the last event in this channel. Client also sends an acknowledge so that the retries stop. So it works kind of similar both ways. And the sequence numbers are different, of course. From server side, the sequence number is basically the number of messages in the channel. And from the client side, each one has a session local sequence number, which gets reset to 0 when you re-log in.
How do you resolve time sequencing? So if you have 3 messages from a client and some of them are older, or they say that they're older, do they wind up in the correct spot in time, or is it
the time of the message? The timestamp of the message gets determined by the server. The server is like a full-blown family of custom C servers. So the WebSocket one is the main thing. So for example, if a client has reported that he has seen a message, server will know. He will then send this seen event to all the other users in the channel. You can see just packing some binary data into a request, like a few meme copies here and there, channel ID, user ID, and then it enqueues. The IO during IP is very, very nice, but also insane to think about because it's completely asynchronous. If you submit a send, you must make sure that the address of the buffer that you submitted stays valid until the IO URIN has processed the request, which is not completely trivial, considering that you can have things like reallocs and moving memory around. So it is all based on like this virtual memory-backed stable growing buffers. So I do the reserve plus commit trick, but I guess on Linux it's a bit different. It's like a map plus and protect, and it's a bunch of crap. Honestly, like I spent maybe a few months working on it in my spare time, then maybe a year working on it, not full time, but maybe half time at work, and then we decided to open source it. And since then, I haven't touched it.
It's open source. That's super cool.
Right. Yeah. It's MIT. You can look at it.
So I can run it myself?
If you dare. The whole README, like with examples on how you run it. Right.
Yep.
And besides the main WebSocket thing, I also have like this upload server, which supports posing file uploads. So, for example, if your connection broke, it creates the upload ID, which you can then query, and it will report how much it already dumped to disk. So you can start like in the middle.
Very nice.
It also creates previews for the images with a very unsafe library, which you should not use in production. And the third thing is the notification, which is not completely finished. It's like 95% finished. It's a working MVP, not integrated with the main thing. This is the push API client implementation. So it's a separate thing that sends out push notifications to vendors of the browsers, such that you can get push notifications when the application is closed, which is, I guess, quite important to have for a chat app.
Yep, makes sense. You do authentication?
Yes, of course. There is like an admin panel. You can add users. You can go to dark mode if you want.
Nice.
All designed by your how do you say it? By me, basically. Yeah, yours truly, right. It has file attachments with image previews. You can like go read through those. You can look at all attachments. You can look at all people. You can search, which works instantly because it's just a for loop.
Oh my gosh.
Yeah, that's true. Not the most impressive example on screen right now. There are like 100 messages maybe, but it works the same for 100K. I did benchmark it.
Is it like a fuzzy find search, or are you doing?
No. It's a for loop dot includes. It's in JavaScript. Remember?
I did a test project a while back where I downloaded the Handmade Hero episode guide, all of Miblo's annotations from the years and years that Casey ran Handmade Hero.
I remember that one. Yeah.
It was like a stress test of different JavaScript frameworks. You said that you were appending items to the DOM like 10 at a time here, 10 messages at a time or whatever. And that's more or less how the Handmade Hero episode search works as well. If you go to like guide.handmadehero.org. So
I referenced it quite heavily during development.
And it really is funny to me. If you just do the naive thing of searching and then rendering, creating all the DOM elements and then dumping them into the DOM, it's like maybe 10 milliseconds to search every annotation ever and just do the string search.
Yeah.
And then like 100 milliseconds to create all the DOM elements, and then like 100 to 1,000 milliseconds to actually do the layout and render. And sad that you have to do the like increment, like adding elements 10 at a time thing.
If you remember the iconic data-oriented talk by Mike Acton, he would talk about the Spider-Man game. The rate of data that they have to deal with depends on the movement speed of the character. It's kind of the same problem here, right? You just have to be quick enough to append elements smoothly, faster than the user can scroll.
That was also true of the episode guide search.
Yeah.
And that was a fun project. And like I tried doing the same thing in all of the different frameworks I could find. I did React and Vue and Svelte, and it was absolutely impossible to achieve the same kind of performance. Like some of them came kind of close, but mostly they didn't. And it was just really, really sad. And also the Svelte one used so much memory that it would like crash the tab.
I have like, I guess, 6 years of professional web dev experience on a role that you could, I guess, call unsupervised full stack. So I always like was in charge of the backend and the front end. There was never anyone who would tell me which technologies to use. So I ended up doing most of that in like vanilla JS, which worked fine at my job actually, but also that's how I write everything. And so when you talk about like Next.js and React and whatever, I of course heard of them, but I've never written a line of React in my life, despite being like pretty experienced web developer.
Lucky you.
Yes. So maybe that helped keep my mental model, I guess, in shape of how things should be, at least in the browser.
Well, I think it clearly has, because the things that you're doing are, for whatever reason, the kinds of things that people in the web dev space are actually afraid to do most of the time. You know, taking control of rendering and like controlling how elements are appended to the DOM. You don't just append things to the DOM. That's like really hard to do, right? And you're like, oh, I just downloaded it and, you know, I parsed this binary format and then I store the results in IndexedDB or local storage. And it's like, oh my God, you just use IndexedDB without wrapping it in some other library, you know.
I don't even use the index.
Well,
sorry, the door just opened behind me. It just does that. That's okay. I don't even use IndexedDB in its intended way, right? I don't store rows. I just use a single key with a single value, which is like a huge array of data.
There you go.
So I use it just as persistent storage, because local storage has a limit on size, which is pretty small. It's like a few dozens of megabytes, I think.
Yeah.
And IndexedDB is limited just by the disk. Maybe let's look at the pipeline viewer.
I guess you said you had 16 years of
no, not 16. 6 years. I am just 27 years. That would
60
be nice.
Years of web dev.
Yeah, in web dev years, you suddenly pivoted to working on CPUs.
But before that, let me close.
Yeah.
It's under me. I went like to work straight during the beginning of the third year. I did basically, as I said, full stack web dev. And during that time was when I got familiar with Handmade Hero and the Handmade Network and adjacent communities. And so I was just doing some stuff on the side that I thought was fun, like writing ray tracer following Handmade Ray. But funny enough, I didn't strictly follow it. I went like, 15 minutes ahead of Casey in the video. And because of that, I spent several hours fixing bugs that he then later fixed in a single minute. I did like a ray tracer, some simple debugging. I think I did a rudimentary dwarf parser, some debugging on Linux, experiments with ptrace, just some projects on the side, just the ones that interested me. Over the time, it became quite clear that I'm interested in like CPU performance, all the nitty-gritty details. But it was, to put it gently, completely unapplicable to my work activities. The closest I ever got at work to doing any serious work, an adjacent team came to me with some graph layouting problem, which was very slow. And they heard somewhere that I'm like the optimization guy. And so I rewrote it from their interpreted language of choice, which I shall not name, to C, then did some self-reportedly serious profiling, fixed a few issues, and it went, I think, from taking 24 hours to, what was it? I think under a minute was the final time for the problem. Yep. But I don't think it went anywhere beyond that at work. I had some knowledge in CPU microarchitecture, which I was not too sure was even correct, because I never seriously talked with anyone at length who knew that stuff. I had a job which was fine, but I think I wanted to do something else. And I had like maybe 2 days of professional experience relevant to the performance, actual like low-level performance work. So what I did, and some of you could have could have seen it live in the jobs channel on the Handmade Hero Discord. What I did was like open up my resume and send it over to some game shops, because I wanted to work in game engine development, which is I guess a phase everyone goes through at some point or another. The 3, I think, or 4 places I sent the resume to, they all declined. But I left the resume open. Why not? And the next day, some people contacted me from a CPU shop. So they make a new RISC-V CPU, and the position is like a performance modeling. So what you do there is microarchitectural benchmarks, and use those then to analyze your own CPU to find bottlenecks, and analyze competitive CPUs to figure out how their microarchitecture works, so that maybe you can get inspired. So that sounded very interesting, and I went to the interview, which I was very nervous about because I have never done an interview in my life. And also I was going to interview about the subject that I have basically zero work experience of. But it went really well. And it's been almost a year on that position, and actually more than a year since I did the interview. And it's been amazing. I've been doing the things I described and other undisclosed activities, but also related and very interesting. The recent one, which I can share a little bit because it was done in spare time during the Christmas break, was CPU pipeline visualization. So when you design a CPU, you obviously can't make an actual chip like every week to test. So what you have are several tiers of slower and slower emulation. The fastest one is like QEMU, which is basically just functional emulation, where the code will run and you can see if the result is correct, but it will not have any performance characteristics. There won't be anything like the real thing. The next tier is FPGAs. You like bake an FPGA bitstream of your design and run on an FPGA, but there are problems with that because FPGA resources are very limited. FPGAs are extremely expensive. They cost like tens of thousands of dollars for the scale that you want for an actual like big core. Wow. $10,000 like per one FPGA. And you, of course, want to have several if you have several engineers. But that works at like approximately 10 to 30 megahertz. So it would already be like 50 times slower than an actual CPU. And then you have two even slower tiers. You can have like an extremely precise clock accurate simulator, which runs the actual design, like at the logic gate level. But it's really slow. It's like 5,000 instructions per second slow. And then there's like a middle ground where you have not so precise but faster simulation. And so these simulators, they support outputting these things called traces. So that's about how it looks. Each new row is a new instruction that the CPU executed.
Yep.
And it's not like disassembly where you will see a cycle as a few instructions at the jump, but it actually is each instruction that the CPU executed. So if it's a loop that was executed 1,000,000 times, you will see the same 4 instructions executed 1,000,000 times, like listed 1,000,000 times on the left here.
Okay.
And from left to right are CPU cycle clocks. So this is a clock, then the next clock, the next clock, the next clock, etc. And if your CPU is pipelined, I won't go into details here what that means, but basically several things can be happening at the same clock. Yep. So if it's in the same row, it will be in the same clock. And so these tools are very useful for very detailed performance analysis. So you would like look at a pipeline stage and see why is it so long? What was happening at the same clock? Why did this block here? It's a stall here, I guess, etc., etc. And performance engineers use these tools a lot. But this open source one, it's very crappy and slow. I guess you can see the if you can see it over the screen share, it's not a good sign. Also, you can see the CPU use, I guess, jump to 25%, and it even jumps to like a level of detail with no coloring because it can't handle rendering any more zoomed out content. And there are a lot of like choices made inside this application that just make the work hard. For example, figuring out like what happened on this clock cycle going up here is not very easy. You have to like basically apply a ruler to the screen, or maybe take a screenshot or something else. Like use some tooling available to you. Like actual experienced performance engineers bring out the ruler, right? But these traces, they do get very, very, very big. So
what are we talking about in terms of size?
Like terabytes.
Excellent. Okay, cool.
Right. So, but obviously, I'm not opening terabytes even in my viewer. No, there is no reason to review like 2 billion clock trace in a viewer because you won't be able to like.
I don't remember. Is MIPS fixed with instructions? Sorry, not MIPS.
RISC-V. Yeah. There is like an extension which supports 2 byte, but basically, all instructions are 4 bytes.
Okay, that actually makes your life a little bit easier, I guess.
Well, it's not actually related in any way to the pipeline because you're not getting instructions encoded as instructions here.
Oh, interesting.
You are getting only events of pipeline stages, like these pipeline stages at this cycle started and then finished, then cycle advanced, etc., and you get like labels. The format is very readable, which is, I guess, a bad thing, but it's this thing.
Oh my!
There are like instruction IDs. S means pipeline start, stage start. E means end. L is a label, and R is retire. So the instruction has finished. That's exactly what I'm doing at work right now. But we are making a binary format. Shows 2 to 3 orders of magnitude compression over the text one. So I made the viewer, which is basically the Whiteboard project, but repackaged. It does all the same things. If I can quickly convert.
Noticing some vertical lines.
Right. You have a keen eye, Ben. Currently, my viewer is basically the same thing, except it, of course, renders everything. I have a very rudimentary level of detail system right now. It's just the labels disappear, or not the labels, but the text disappears when you zoom out. And then at some point, the borders disappear, like here. I'm not even sure if it's visible. And at some point, like maybe here, it would make sense to merge every line into a single quad. Because, I have been opening some traces that have, let's say, 100 million of those. That's not fun for the GPU to chew through if you specify each pixel as 12 separate quads. The most important thing is that I have a current cycle highlighter, so you can actually see what's happening on the same cycle.
Yeah, that's kind of a no-brainer. So,
right, exactly.
How do people typically find things in these files?
Right. So usually you either have a specific cycle you want to look at. So the interesting thing happens around cycle 1 billion or whatever.
Right. Yep.
Another way is if there is a region of code that you're interested in and you can modify it, you insert what's called a magic instruction, which is the thing that you never see in regular code. For example, RISC-V, it would be X or 000, X or the 0 register and write it to nowhere, which is not something the compiler generates. And then you just use the instruction view on the left to find the instruction, via text search. Another way, which might, I think, be pretty interesting, is that you can often see the region of interest by eye because it looks funny. If you recall that horizontally, basically the passage of time, while vertically is the passage of instructions, the slope of the trace is basically the efficiency. Formally speaking, it's instructions per clock, right? IPC. So the slope denotes the IPC. And if it's low, for example, like here, the slope would be it will be almost horizontal, which means that almost no instructions are executing at the same time. And if it's closer to vertical, it means that you are going very quickly because a lot of instructions are in the pipeline at at the same clock. You are doing 20 instructions at the same time. And so you can very often find the region just by eye. You zoom out really far and you can say, oh, okay, so this staircase, for example, pattern or whatever is the one I'm looking for. And you just zoom in, you look at the instructions and you are there. And you can easily find the start of the loop because it's very visually noticeable.
This seems like it's right for a couple of different kinds of graphs to help you navigate as well. If you get big traces, something that tells you here's your slope over time.
Yes, absolutely. We have tools for that. Is all I will say.
Yeah.
But what I can say is that no one is preventing you from adding question mark instruction ID equals whatever 123 to the URL. And then if you have a separate tool that allows you to, example, perf, which helps you find hotspots, You can then link from that tool, if you are controlling it, to the
Okay.
region of interest in the trace.
Cool.
At first, maybe glance, they look nothing alike. But this is all instance quads, right?
Yep.
So all instance quads with a pan and zoom interface, like on the map, with a level of detail engine somewhere in there, and some rudimentary UI above. The main knowledge base and the main skill set is very transferable, which is basically how I managed to bang this thing out in like a week or maybe a few days even. Like the first prototype was made during the visibility jam in Handmade Network. If I have any specialization, it appears to be like instance quad renderer.
Well, I know that feeling.
Which is surprisingly it is a surprisingly rare skill to have. So people were not like satisfied with the open source tool I showed. I have heard lots and lots of justifications from very qualified performance engineers as to why it is so laggy and bled.
Yes, so I ran into this one on my end, doing almost identical problems, like a log tree with instance quads.
Right, for SPAL, right?
Yeah, and it's exactly the same thing. You get the like, well, insert your favorite performance tool here is slow because it's a hard problem. I swear, it's like the rendering is not the hard problem, actually.
Part of what prompted you to make SPAL, as I recall, was that Perfetto came out and was so bad at viewing trace data.
They were all bad. But the the same thing applies here, I'm sure, because the same group of people, the same like rough bubble of people exist in both spaces. It's I need some performance tool, and I'm not sure how like performance engineer, but has no idea how performance outside of the bubble works. But yeah, it seems to be pervasive.
Right, which is very surprising to me, right? These guys know very well how fast the CPU can go, but in absolutely no relation to any end user workload,
right?
Which is a common problem.
Yeah, well, I've seen some of the same in my time at Mozilla.
The biggest thing I wish we could give as a takeaway is like for a 2D plane, your eyeballs aren't that great, right? Like it's actually hard to stuff enough quads that you can see and make out on a 2D plane to have a GPU performance issue as long as you're not overlapping them, right? Like it's not a rendering problem with the things you can fit on the screen.
Speaking of, peeps the GPU frame time. Yeah, but you're absolutely right. As I got more accustomed to these 2D tools dealing with lots of data, it's all level of detail and clipping. That's all you need. When you zoomed in, clip the stuff that's off screen. Please do it quickly. And when you're zoomed out, just load it.
And that cuts so much of the data problem out. Like, it's like the rendering is not the issue, right?
Yeah, absolutely. Rendering is only the issue, like if you are doing, but like blending and not in the right order or whatever. Well, rendering will be a problem if you don't like, for example, do loading. The vertex shader will at some point start lagging, like taking too much time if you throw tens of millions of vertices per frame.
Oh, sure, yeah. But you don't...
No one can see 10 million vertices per frame is the point,
that's
right?
The important piece.
Yes, I agree 100%. If anyone is listening it with like a front-end background or maybe a web dev background who wants to go into more low-level CPU work, for example, like performance engineering, which is surprisingly popular, by the way. Our department has like 100 people. I didn't even know such a profession existed before I landed the interview. But if you want to go into something like this, you have a chance. If you actually know your microarchitecture, you have a chance of having a very unique skill set. Because performance engineers, while they are very brilliant, they usually have, not no idea, but very little idea of how actual end-user applications are made. They are not application programmers. If you are like competent in making actual applications, while also being competent in microarchitecture, you can be like, how should I say it without sounding cocky, but you can obtain a very unique skill set, which will be very beneficial to you in all senses. I invite anyone who's interested in performance, but is not doing it, to start doing it right now. And maybe you can make a tool and be everyone's favorite while also working on CPUs, which is very fun.
Awesome. Where do we find you?
2 of the projects listed are open source, but it is public. Just make sure to look at the latest branch. It is not master, as you can see. The chat, it's available on my GitHub. I think it's the pinned repository. Yeah, right. But if you want to run it inside your company or whatever, it's MIT. Use it. Yeah, if you want to do some work to finish up as a push API, I would be very grateful. So yeah, these are the 2 projects. This one is unfortunately not open source and will not be. Yeah, quite probably will not be. But if some interesting details arise, I will maybe post in the Discord what the employer allows.
Well, it's been really great having you, Alex.
Yeah.
Likewise. Nice to speak some English for a change. Yeah.
Yeah, no, this is a wonderful time, and I have been really glad to see your projects in the Discord. You occupy this really fun niche where you can, like you were talking about, bring these low-level, interesting performance challenges and present it in this way that's very accessible to people. Like, seeing you share the link to the Whiteboard app for stress testing and, making that available to people. It's just really cool to see. And I just really love the, all these little apps you've made just because you wanted to.
Yeah. Speaking of stress tests, I would hope one more of those is coming soon, because the last one was like 2 years ago, I think. Since then, for the whiteboard, it's gotten a lot more fun stuff to play with since then.
Sweet.
Yeah. But as I said, thanks for having me.
Yeah.
What's our outro, Colin? How do we do this now?
Outros always suck. So the outro is usually like the chunk where I have the guest give their shtick, their spiel.
We did that.
Right? Yep.
There's going to be another version of Colin awkwardly pasted over the current Colin when this thing eventually goes up. And we'll call it there. We'll mash stuff around in the edit as necessary.